Hello everyone, a very good morning all of you and a very warm welcome to you all to the India's largest, the best and your favorite platform, BYJU'S Exam Prep. कैसे हैं सब लोग? What's up? Can you guys hear me? So this is Chandra Shekhar. I welcome everyone to the beautiful session, practice session for HPCL examination. You all know that HPCL is going to be a golden opportunity for all the mechanical aspirants. So we are here to help you out in every possible manner. And today I will be discussing some of the beautiful numericals, beautiful questions from the subject of industrial engineering. Alright, so the topic to be covered in today's session will be LPP, linear programming problem, transportation model, assignment model, and the queuing theory. There are 20 questions in total and we will try to cover all the questions along with the related concept in next 45 to 50 minutes. Alright, but before that, please do let me know if I'm audible and visible to all of you perfectly. And do like this session, share this session to all your friends so that more and more people can join and everyone get benefited. Keep your pen, notebook and calculator handy. The more you give the answer, the more you do on your own, the more understanding you get from the concept. Alright. So shall we start? For those who are meeting me for the very first time, this is my quick and brief introduction. My name is Chandra Shekhar, as I have already told you. I am a mechanical engineering graduate from IIT Delhi. Yes, Umar. Right. Do not keep your calculator because it is not allowed in HPCL examination. Correct. So I am having more than 10 years of teaching experience in GATE, IES and PSUs. I am graduate from IIT Delhi in mechanical engineering, cleared the engineering services examination, also worked in SAIL for a couple of years, and I am quite comfortable in these many subjects of mechanical engineering. If anybody is having any doubt in any of the topics of mechanical engineering or any general doubt, you can always contact me through the official mail ID which is there on the screen. And if you have not joined me yet on the Telegram group, I would request everyone to join me on the Telegram so that we can be more connected with each other and I will help you out in a better way to clear your respective competitive examination. Through the Telegram group, I will provide you all the exam notifications. After this session also, I will provide the PDF of this session and study notes are also going to be provided. So joining the Telegram group will always help you in improving your chances of selection in the competitive exam. The group is Mechanical by Chandra Shekhar and the link is also there on the screen. And before we proceed further, there is very important announcement. So many students are already aware about that, but still those who are not knowing that we are going to bring a very important and beautiful series for all the GATE aspirants, the numerical practice series. Here we will be going to discuss more than 500 questions which are having the difficulty level as that of your actual GATE examination. The series is going to be started from 25th August on BYJU'S YouTube channel, that is completely free. Once you will attend this series with your full dedication and religiously, definitely you will see the difference in your confidence level. You will definitely have the better chances of getting the good rank in the upcoming GATE examination, GATE 2020. Alright, so share this information to all your friends because the series is not only for mechanical engineering, for each and every branch the series is going to be conducted. So we will discuss more than 500 questions in our technical syllabus of mechanical engineering starting from 25th. Alright, so let us start solving the questions without wasting much of your time. So first the questions will be from LPP, then transportation, then assignment and finally queuing theory. The answer to the question, I want everyone to respond. A feasible solution to LPP should. There are three types of solution. One is feasible solution. Another is basic feasible solution. You must be knowing the difference between these. Basic feasible solution and the third one is optimum solution. First of all, we find out the feasible solution. That is the common region which satisfy all the constraints. That is the feasible solution. What is the basic feasible solution? The corner points which are probable candidates of optimum solution, and one of the corner points is optimum. One of the corner. Isn't it? What will be the correct answer? So the question is only about the feasible solution. Then the feasible solution is the one which satisfy all the problem constraint and no negative restrictions as well. This is also no negative restriction is also a constraint. Non-negative restriction. You must be knowing. X and Y should be positive. So if we draw all the restriction, the common region is called as feasible solution. The common region, all the constraints along with the non-negative restriction is the. So D is not correct answer. It is C which is more appropriate. A and D, combination of A and D will be more appropriate answer. Option C is the right answer. Good morning, Shubham. Welcome, Pragnesh, Umar. Welcome, guys. Welcome to the session. Let us move to the next question. That is from the dual. Do you know what is dual of a primal? Why do we use dual? When the number of variables are more, it becomes difficult to solve. It becomes impossible to solve using the graphical method, and at the same time it becomes difficult to solve using the simplex method also. So what we do is we develop the dual of a primal problem, and the solution to the dual problem will be the solution to the primal problem. So if we develop the dual, B for Bombay, what is the correct answer? It is again mix and match. The primal is having 6 variables. The number of variables of the primal is equal to number of constraints of the dual, and number of constraints in primal will be number of dual variables, isn't it? That is how dual from a primal dual is developed. And if the primal is maximization problem, the dual will become minimization. So because the primal problem is having 6 variables and 2 constraints, so the dual will have 2 variables and 6 constraints. 1 is correct, 2 is incorrect, and the primal is maximization problem, so the dual is minimization of the objective function. 1 and 4 is correct. Option B. B is the right answer. 1 and 4. Option B. B is the right answer. Alright. Question number 3. For the graphical method, the most simple method is graphical method when the decision variables are 2. For 2 decision variables. For 2 decision variables x and y or x1 and x2, we can use the graphical method to solve LPP. In linear programming problem, which one of the following is correct for graphical method? A point in the feasible region is not a solution to the problem. That is incorrect. Any point in the feasible region, if I draw, this is, let us say, x, this is y, and x is greater than 0, y is also non-negative, and if there are constraints, let us say one constraint is this, another is this. So this is the feasible region. Any point in the feasible region is a feasible solution. Any point in the common region is a feasible solution. Any point in the feasible region means common region of all the constraints. Is not a solution, it definitely a solution, that is called as feasible solution. One of the corner points, out of these corner points are known as basic feasible solution. One of the corner points of the feasible region is not the optimum solution, that is also incorrect. One of the corner point will become the optimum solution. I have told you. Out of the basic feasible solution, one of them will be the optimum solution. Any point in the positive quadrant does not satisfy the non-negative constraint. All the point in the positive quadrant will satisfy the non-negative constraint. C is also incorrect. The lines corresponding to the different value of objective function. Objective function is Z. The line which is corresponding to different values of objective functions are parallel to each other. Yes, for different value of objective function, they are parallel because the slopes are constants. Because all the lines having the different value of objective functions are having equal slope. What is the slope? Slope is equal to minus coefficient of x upon coefficient of, that is, so option D is correct. The slope will remain constant. The slope will remain constant and the slope will remain constant. Then the lines will be parallel to each other. Isn't it option D? And do you know one more thing? Do you know one more important thing? That the feasible region is always convex. The feasible region is always convex in LPP model because of due to linear nature of constraints and objective function. Due to linear constraint. In linear programming problem, all are linear functions. So this is convex. The shape of the feasible region or the common region is always convex. Option D is the right answer for this question. What about question number 4? There are different type of solution in LPP. One is infeasible solution, degenerate, unbounded, unique solution, multiple or alternate solution. When we talk about the graphical method, if the constraint line of one of the non-redundant constraint, what is non-redundant constraint? Which is part of the feasible region. The constraint which is part of the feasible region or which is part of the common region is parallel to the objective function line that it indicates. What is the correct answer? There are two types of constraints. Let us say this is the feasible region. This is a feasible region. This is constraint number 1, 2 and 3. So constraint number 3 is redundant because it is not part of the feasible region. It does not involve in the feasible. Redundant. And 1 and 2 are non-redundant. 1 and 2 are non-redundant. So if the objective function is parallel to, the one of the redundant, non-redundant constraint, then it may imply multiple or alternate solution. It may imply multiple or alternate solution. Option D is the right answer. When do we have infeasible solution? When do we have infeasible solution? When there is no common region. The region satisfying all the constraints will not be there. Then it is infeasible solution. When do we have degenerate solution? When an optimum point is overdetermined. Optimum point is overdetermined. What is the meaning of overdetermined? For an example, this is 1, this is 2. There are two constraints and this is the optimum point, let us say. This is the optimum point. So this optimum point is the intersection of 3 lines, isn't it? It is the intersection of 3 lines. 1, 2 and vertical line. So this optimum point is actually overdetermined because the intersection point of 2 lines, it could have been the intersection of 2 lines even. Could have been the, so that is why, because the point, optimum point is overdetermined, this is the common intersection of 3 lines, that is why it is degenerate solution. And what is unbounded solution? When the feasible region is there, common region is there, but we are not able to find out the optimum point. We cannot find out optimum point due to restriction in the constraints. Due to restriction, we can't find optimum point. Then it is unbounded solution. So option D is the right answer for the given problem, question number 4. Question number 5. The degenerate means degenerate does not create a problem in LPP model. In LPP model, degeneracy does not create a problem. Degeneracy means even if we do one more iteration, then we will not make the optimum point to be more optimum. So the optimum point, one more iteration will give you the same result. That is the meaning of degeneracy. That is the meaning of degeneracy. In case of graphical method, how do we define the degeneracy? When any optimum point is overdetermined. If more than two constraints are lying on the optimum point, it means the optimum point is overdetermined. So it will remain the optimum point only. It will not create a problem as such, but because the next iteration will not make the solution further optimum. That is the meaning of degeneracy, Umar. Right? Consider the following statements regarding the characteristic of standard form of LPP model. All the constraints are expressed in the form of equations using slack and surplus variable. You must be knowing that is one of the steps in analyzing or in solving the LPP using simplex method. That is correct. The RHS of the every constraint equation must be non-negative. That is also correct. If it is negative, multiply the whole equation with negative sign. 2 is also correct. All the decision variables must be non-negative. X and Y should be greater than 0, 3. All the three statements are correct. In standard form of LPP model, all the three statements are correct. So that is why option A will. Question number 6. If we draw the simplex table like this, the leaving variable. If there is a tie in deciding the leaving variable, the ties are broken arbitrarily. The ties can be broken arbitrarily. If there is a tie for leaving variable in the simplex method, what does it imply? It implies that there is a degeneracy. I have already told you the meaning of degeneracy. Means the further iteration will not make the solution more optimum. So extra iteration will only give you the same result. That is called as degeneracy. And the degeneracy in simplex method is happening when there is a tie in selecting the leaving variable using the minimum ratio. Using minimum. Right? Option D is the right answer. Question number 7. How do we decide the leaving variable then? How do we decide? How to decide the leaving variable? Leaving variable is selected, that is simplex feasibility condition. The leaving variable is selected for simplex feasibility condition. The leaving variable is selected how? It is the minimum ratio theta. Minimum positive ratio theta. And how the minimum ratio is defined? How the minimum ratio is defined? the minimum positive ratio. Minimum positive ratio. If the ratio is negative, then we will select the higher ratio. If it is negative, Umar, we will select the higher ratio. The minimum positive ratio is the ratio of the RHS divided by the corresponding pivot element, pivot column element. The minimum ratio is the ratio of right hand side to any constraint divided by pivot column element. Right? अभी explain करते हैं. So it is the minimum positive ratio of the right hand side to the coefficient in the key column. Key means pivot column. Option D. Just a second, let me explain. Just hold on. Yes. In simplex method, this is how the table will be drawn. Basic, then x1, x2, s1, s2, etc. Then there will be a solution space and then theta. Here there will be Z-ray coefficient and here will be the basic variables, let us say s1 and s2. Now, how to find out the optimum solution for maximization problem? For maximization problem, if all the Z-ray coefficients are non-negative, Z-ray coefficients, for maximization problem, the entering variable is selected as the non-basic variable with the most negative Z-ray coefficient. When all the Z-ray coefficient becomes non-negative, then it will be optimum. And for minimization problem, all the Z-ray coefficient becomes non-positive, then it is the optimum solution. So when the Z-ray coefficients are, so how to find out the entering variable? The entering variable is the non-basic variable which is having most negative Z-ray coefficient. And for minimization problem, the entering variable is the one which is having most positive Z-ray coefficient. And how to find out the leaving variable? Leaving variable is decided by this ratio theta. Theta is, let us say this is the entering variable, it is having maximum negative. This is the most negative. So this will be the pivot column and the leaving variable will be decided to, let us say 3. Then solution will be, let us say 5, 10, like this. So 10 by 2 will be the minimum ratio. Then let us say this is 4. 4 by 3 will be the minimum ratio. So minimum non-negative ratio will decide the leaving variable. This is how this will be the leaving variable, will be the entering. So there will be multiple solution or alternate solution. It will, the solution, the optimum solution will have alternate or multiple solution when any of the basic variable, when any of the non-basic variable will have 0 Z-ray coefficient. When any of the non-basic variable will have 0 Z-ray coefficient like this, then it will be alternate solution. The alternate solution will be there when any of the non-basic variable will have zero Z-row coefficient. And there is degeneracy in the simplex method when there is a tie in selecting the leaving variable. When there is a tie in minimum ratio, then it is degeneracy. It will be unbounded solution. It will be unbounded solution when all the minimum ratio are negative. When all the minimum ratio becomes negative, or we can say all the elements of a pivot column are negative, then it is unbounded solution, because the pivot element cannot be negative, and it will be infeasible solution when the artificial variable is still present, when the artificial variable is still present in the optimum solution, then it is infeasible. All right, Umar, that is how. Good. Am I right? Question number 8. In the solution of a linear programming problem by simplex method, if during iteration all the ratio of RHS to the coefficient of the entering variable are found to be negative, which solution will it be? Which solution will it be? Infinite number of solution if any non-basic variable have zero Z-row coefficient, then it is infinite number of solution. Infeasible solution, artificial variable still there in optimum matrix. When there is a degeneracy, tie in minimum ratio, then there is a degeneration. An unbounded solution when all the elements of pivot column are negative. So when all the elements of the pivot column are negative, then theta will be negative. Theta will also be negative. That is the minimum ratio. All the ratios will be negative. All the ratios of RHS to the coefficient of entering variable are found to be negative. Option D is the correct answer. Question number 8, option D, isn't it? नहीं उमर, अनबाउंडेड का मतलब है there is a solution. Unbounded means there is a solution, but we cannot find it out. There is a solution. For an example, if the common region is like this, if let us say this is the common region and the problem is maximization problem, so the optimum point will keep on moving. We do not know. For maximization problem we cannot find out. This is called as unbounded. There is no bounded region. The region is open, unbounded. So there is a solution, but we cannot find it out. For minimization problem, it will be unique solution. For minimization problem, this point will give you the minimum value of Z. For minimization problem, it will be unique solution, but for maximization problem, it will be unbounded. No infeasible solution means no common region. No common region. Infeasible solution is no common region. All right. While solving the problem by big M method, if the objective function rho shows optimality, when do we have the optimum solution? I have already told you. For maximization problem, when all the Z-row coefficient becomes non-negative. For minimization problem, when all the Z-row coefficient becomes non-positive, that is the optimum solution. Optimum solution. For maximization problem, all Z-row coefficients non-negative, that is optimum. For minimization problem, all the Z-row coefficient becomes non-positive, So if there is an optimality, but one or more artificial variables are still there in the basis, and what type of solution does it show? It is infeasible solution. I have already told you. Yes, Umar. It will be infeasible. Isn't it? Question number 10. Question number 10. Which one of the following statements is not correct? You should clearly read the question. Which one of them is not correct? In LPP with 2 variables and 3 constraints can be solved by graphical method. That is correct. LPP can be solved by graphical method when it is having 2 variables. For 2 variables problem, we can use the graphical method. For more than 2 variables, the graphical method cannot be used. So first statement is correct. In big M method, if the artificial variable cannot be driven out, it depicts optimum solution. That is incorrect. What it depicts? It depicts infeasible solution. It depicts infeasible solution. That is incorrect. Dual of a dual is a primal. That is correct. Primal. Then we make the dual. And if we make the dual of this dual, then it will become primal. That is correct. For mixed constraints means either less than equal to or greater than equal to sign. That is called as mixed constraints. For the mixed constraints, either big M method or two-phase method can be employed. That is also correct. So the statement which is not correct is option B. B is the statement which is incorrect. For the 10th question, the answer will be option. Now for transportation problem, which one of the following is not the solution method of transportation problem? This is for assignment problem. This is method used for assignment problem. These are the methods used for transport. Northwest corner method, least cost method, and Vogel approximation method are used for transport. So option A is the correct answer. That is for assignment problem. Hungarian method. Question number 12. In a transportation problem, northwest corner method would yield. All these methods gives initial feasible solution. It does not give optimum solution. That these methods are used to start the solution. Then optimality will be achieved. Then we go for optimum by using optimum is determined by using UV method, or we can call it as method of multiplier, or we can call it as water value method. This method is for optimality. So question number 12, in a transportation problem, northwest corner method would yield. It will not optimum solution. It will not give Vogel approximate solution. It will not give minimum cost solution. It will give initial feasible solution. The northwest corner method will give initial feasible solution. The optimum solution is given by UV or method of multipliers. Question number 13. In order for a transportation matrix which has 6 rows and 4 columns not to be degenerate. For no degeneracy, number of basic variables should be equal to number of independent constraints. That is the condition. What is the number of basic variable? Number of allocated cells. In case of transportation, it is equal to number of allocated cells. Number of allocated cell is equal to number of independent constraints will be m plus 1 will be total constraint, and 1 is dependent. M plus n minus 1. M is the number of rows. N is the number of columns. For no degeneracy, so rows is 6, column is 4. So number of allocated cell must be equal to 6 plus 4. That is equal. Number of allocated cell must be equal to 9. Option B is the correct answer. Option B. Question number 14. Give me the answer for question number 14. You all are supposed to give me the answer for this. LHS will be OR techniques and right hand side will be the application. Linear programming is used for product mix decision. How much X1 and X2 are mixed together to get the final product. Product mix decision. Transportation, to minimize the transportation cost. Warehouse location decision. Q1. Assignment problem, which job is assigned to which machine, so the total cost or total time taken becomes minimum. Assignment is machine allocation decision. And queuing theory is used to make a balance between the cost of offering a service and cost associated with waiting time. So it is related with the number of servers decision. So P3, Q1, R2 and S5. P1 to 5. 14, B. B is the correct answer. Yes, Kiran. Very nice. Please share the link of this class and do like this session so that it reaches to all the students who are not able to come live, but they can watch the recordings later on. Question number 15. Consider the following statements with respect to the assignment method of optimization. The matrix format of the method must be square matrix. Is this correct? Statement 1 is correct. Yes, it should be square matrix. If it is not, then we can make it square by adding a row or a column as per the requirement. With zero time duration. Some type of rating has to be given to the performance of each pairing. Assignment method is not related with the performance. It is not related to the performance. It is related to the time taken by a machine to do a particular task. It is not related with the performance. So there is no rating to be given for the pair. So the correct answer is which of the following statements are correct? Only one is correct. Option A. Only one is correct. Assignment method is not related to the performance. Question number 16. Nain Umar, it can be maximization also. Profit, if the assignment matrix is given for profits, it can be maximization. But we need to convert it into minimization problem by multiplying with minus. By multiplying all the elements with negative sign. -1. Even if it is maximization problem, we can convert it into minimization problem. What about question number? Hi Pratham, good morning, welcome. Question number 16. In an assignment problem having n facilities and n jobs, the total number of machines are n and n jobs. What is the number of possible ways of making assignments? If it is 2 machine and 2 job, let us say, what are the possible ways? Possible ways will be 2 factorial. It can be 1a and 2b, or it can be 1b and 2a. These are the possible ways. So it is 2 factorial, 2 into 1. There are two ways. One job is assigned to a machine A and 2 is assigned to machine B, or it can be 1 is assigned to B and 2 is assigned to A. So it will be n factorial. It will be n factorial, n into n minus 1 to n minus 1. That is n. How we can find it out? For assigning job 1, there are two options, two possibilities. So 2, then because for the second job, there is only one option. So 2 into 1. Similarly, for n jobs and n machines, it is n factorial, n into n minus 1 into n minus 1. And in assignment problem, there is always degeneracy. Always degeneracy. Why? If we say m plus n minus 1, what is the number of allocated cell? Number of, if n facilities and n jobs, allocated cell will be equal to n. The number of allocated cells or basic variables is equal to n. Finally, basic variable will be equal to n only, which is less than n plus n minus 1, isn't it? That is the number of constraints. There is always a degeneracy in assignment problem. Number of constraints will be equal to number of independent constraints will be n plus n is the number of rows, n is the number of column, n plus n minus 1. So there is always a degeneracy in case of assignment problem. Question number 17. Four more questions to go. That is with respect to queuing model. The question is from the queuing model. A dedicated machine receives jobs at the rate of 20 per hour. So lambda arrival rate is 20 per hour. That is the arrival rate. And the process rate of machine 30 jobs per hour. Mu is equal to 30 jobs per hour. That is the departure rate. Inter-arrival time and processes time jobs follow exponential distribution. Queuing discipline is FCFS. Queue capacity and job population are infinite. For how much time in minute on an average does a job has to wait before it gets loaded on the machine? So waiting time in the queue need to be calculated. That a job has to wait before it gets loaded on the machine. So when the turn of that particular job comes, how much is the waiting time in the queue? Waiting time in the queue we need to calculate, isn't it? We need to calculate waiting time in the queue. You should understand basic formula in queuing model. One is little formula. What is little formula? LS is equal to lambda into WS and LQ is equal to lambda into WQ. These are little formula. These are called as little formula. LS is the length of the system. LQ is the length of the queue. Another formula are the waiting time in the system is waiting time in the queue plus service time 1 by mu. If we multiply with lambda, that is another formula. If we multiply with lambda by lambda, so lambda WS is equal to lambda WQ plus lambda by mu. That will give what is lambda into WS, that is LS is equal to LQ plus rho. Rho is called as utilization factor. That is another formula. And one more formula is LS is equal to rho upon 1. That is the length. These are some of the basic formula you must remember. If we want WQ, then we can say it is LQ by lambda. Isn't it? WQ is equal to LQ by lambda. And 1 by lambda, what is LQ? LQ can be written as LS minus rho. And what is LS? LS can be written as, so it is 1 upon lambda, then rho upon 1 minus rho. This will put the values, you will get the answer. Put the values, So rho is equal to 20 by 30. That is 2. Can you do the calculation? The answer should be in minute. So it will be 60 multiplied by this. Are you getting option A or not? Are you guys getting option A or not? Isn't it option A? Isn't it option A? 1 upon lambda 3 by 20. Then rho upon 1 minus rho. Rho is 2 by 3. By 3 upon 1 by 3 minus by 3. Two minus 2 by 3. Right? 4 minutes. What about question number 18? Question number 18. As per Kendall notation in Markovian queuing system, M for Markovian, the number of arrivals in a fixed time follows. The arrival rate follows Poisson distribution. Arrival rate follows Poisson distribution and inter-arrival time follows exponential and service time. Service time follows exponential. Option C is the correct answer. Question number 19, second last question for the day. Customers arrive at a service counter named by a single person according to a Poisson distribution with a mean arrival rate of 30 per hour. Lambda is 30 per hour. The time required to service a customer follows an exponential distribution with a mean of 100 seconds. So mu is equal to 1 by 100 per second. Convert it into R. Convert it into R. It will be 3600. That is per hour. The average waiting time of customer in the system. Waiting time in the system. WS. What is WS? That is LS upon lambda. LS is rho upon 1 minus rho. 1 by lambda. The values. So lambda by mu, that is rho is equal to 30 by 36. 5 by 6. WS will be equal to rho, that is 5 by 6 upon 1 by 6 into 1 upon. Isn't it? In hours. That is equal to 5 by 30. 1 by 6. 1 by 6 hours. What is 1 by 6? 0.166. Option B is the correct answer. Option B. B will be the answer. Question number 20, last one. On an average, there are 30 customers in a queue. That is length of the system, sorry, LQ. Length of the queue is the number of customers in the queue is 30. If the arrival rate of the customer into the system is 16 customers per hour, lambda is 16 customers per hour, and on average 32 customers leave the system per hour. Mu is 32 customers per hour, departure rate or service rate. Then the average number of customers in the system, LS. LS is equal to LQ plus rho, isn't it? LQ we all know. What is rho? Rho is equal to lambda by mu, that is 6 by 32, 1 by 2. It will be 30 plus 1 by 2, 30. For question number 20, it is option B. 30.5 customers will be there in the, isn't it? So that is all from my side for the day. I will see you again in the next session. Till then, enjoy, take care, and have a good day and a great future ahead. So please do join me. If you have not joined me on the Telegram, you are most welcome to be part of my Telegram group. And stay safe, stay motivated, and keep doing the hard work with your full dedication and full positive mind. That is all from my side. See you in the next session. Thank you and Jai Hind.